Selecting a flow meter isn't as simple as just deciding on which technology to use or even which manufacturer's equipment to use. There's much more to it than that, and often there's no correct answer. You actually have to take a holistic view of the whole process. Only after you've done that and you've understood what you're trying to measure, then you can understand what the best way of measuring it is and start to then home in on the most appropriate method and most appropriate suppliers for your equipment. The selection process will start by listing the factors that are going to influence the meter and then working through those in turn to decide on the appropriate solutions. And there are basically 5 factors that you need to consider. They are fluid, performance requirements, installation, environmental and economic issues. The nature of the fluid will directly influence the choice of flow meter, as not all flow meters can be used for all fluids and fluid applications. The range of information that you need includes things like, is it a gas or a liquid that you're dealing with? What pressure conditions, temperature conditions, what's the density of the fluid, the viscosity of the fluid? Is it corrosive? Is it hazardous? So you need to be able to supply all of that information for the fluid. The reason the measurement is being made has to be defined, and it's often omitted as being obvious, but that's the starting point. So you have to ask, what's the range of measurements required? What's the minimum value and the maximum value you're covering? What's the duty point? That's the point at which most of the measurements are going to be made. You then need to look to see what the required uncertainties are across the range. For example, you might want very low uncertainty at the duty point, but accept higher uncertainties at other points in the range where it's only process indication. If you required low uncertainty across the whole range, for example, then you might have to consider the use of multiple flow meters to cover the range and the uncertainty required. The meter installation requirements are of paramount importance for the performance of the meter, and there's a range of issues you have to deal with, in particular with regard to the placement of the meter. In the real world, you're probably going to have minimum space in which to install the meter, and that's going to impose compromises on the performance of the meter. You have to take account of the effects of things like bends and fittings on the flow profile, because that will affect the performance of the meter. Different meter technologies will be affected in different ways by those effects. But whereas in the ideal world, the manufacturer might specify 40 or even 50 diameters of straight length upstream of the meter, in the real world, you're not going to have that. So you need to know what those effects are going to have on the performance of the meter, and that's driven by the installation that you can actually put the meter into. Well, for example, can you actually break into the existing pipe run to install the meter at that location? And once you've got it there, what access do you have to that location for removing and replacing the meter subsequently, for maintenance, for calibration, or even to read the data if you don't have remote reading capability on the meter? We've spoken about the installation effects. So do you actually need to put flow conditioners in there? Have you got space at that location? And taking all of that together, what's the impact going to be on the uncertainty that you will achieve from that flow meter in that particular installation? Short answer, no, except if you're in a hazardous area. Then you're going to have to apply appropriate classifications, for example, intrinsic safety or explosion-proof ratings, but meter manufacturers can generally advise on appropriate technology for those applications. On the other hand, the environment can affect the flow meter. For example, ambient air temperature, humidity, sun, wind, all of these things can affect the meter, and that will be dependent to some extent on the metering technology and also its location, its installation. Another environmental influence that could have an impact would be electromagnetic interference. So all of these things need to be taken into account in deciding on the appropriate technology and on the installation requirements. The economical benefits really come out of understanding how the economics impact with the selection. For example, the value of the fluid that you're measuring has to be assessed. That's basically the economic reason for the measurement that you're making. Now, generally that's obvious, but then you need to balance your capital costs, the purchase cost of the meter, against its subsequent operating costs. Because, for example, purchase price, while it's important, might not be the only factor. A low purchase price may well be offset by other subsequent operating costs. For example, the requirement for additional secondary instrumentation, a more complex installation, or more complex, costly and frequent maintenance requirements. Every requirement is unique, and effectively every installation is different, so there's no perfect choice. But what you can do is start by anticipating trouble, both initially and over the whole lifetime of the meter. Build that in as part of your selection process, and that will help you to get the right choice. Where do you get that sort of help? It's available from a range of sources, including flow meter selection guides from various standards. From the flow meter manufacturers themselves, they have guides on what metering technologies to apply to particular situations. And of course, finally, you can go to independent expert consultants who will provide information on flow metering technologies, installation effects, and all of the other things that we've discussed in the presentation so far.